Good morning. Before I introduce myself, I want you to first cast your mind back to 2010. Many of you may have been stranded in airports. The flights were cancelled, you'd be late to your meeting, you'd be late home to your family. And they said this was because there was ash in the atmosphere, volcanic ash, due to some unpronounceable volcano in Iceland. This Iceland volcano was called Eyjafjallajökull and became infamous. But a lot of this could have been prevented. The models that have been used to forecast where the ash was going lacked important information. They didn't take into account that ash comes in a range of shapes and sizes, which changes depending on the volcano that erupts. So, my name is Emma Nicholson, and I work at the University of Bristol in collaboration with the UK Met Office. And our aim is to improve our characterisation of volcanic ash and then improve the accuracy of these models. So there are several key questions that I want to answer during my research project. The first one is, we want to know more about the physical processes that are involved in producing volcanic ash during an eruption, and specifically, what controls the shape and the size distribution of the ash that's produced. I also want to know the influence of shape and density on how far ash will travel for a given eruption. So to do this research, I collect ash samples, often during the eruption itself, from as many different volcanoes around the world as I can, in order to explore and explain the observed variability that we see in the shapes and the size of ash particles. This is an example of an ash sample from the Eyjafjallajökull eruption. And you can see that it's very inhomogeneous, and this is just from a single volcano. So my research so far has shown that we can often link the differences in the shape and the size to changes in the style of the volcanic eruption itself. If you like, you can think of volcanic ash particles as pieces of a jigsaw, and my research is like we piece the pieces of the jigsaw back together again. Each individual ash particle has a range of fracture surfaces involved, and if we look at these fracture surfaces and put them back together, we can reconstruct what the state of the magma may have been before it erupted. This may be illustrated by this highly simplified example here. If the volcanic plume, the ash cloud, was dominated by blocky ash grains such as this one, putting this back together may suggest that the original magma was gas poor, whereas an abundance of these more thin shards, putting those back together, indicates a much more gas-rich, energetic eruption. So we can use the textural properties of ash to infer things about the eruption itself. Preliminary results have also shown that highly porous ash grains with almost a honeycomb-like texture and low densities travel much, much further than we would predict based purely upon grain size or mass alone. Therefore, shape is key to understanding how the ash is going to behave in the atmosphere. Volcanic ash doesn't just pose a hazard to aviation. It can impact agriculture, critical infrastructure, and public health. As ash particles are respirable, you can breathe them in. So the insights from my research project will help to minimise the risks posed by future volcanic eruptions, and so that next time, neither you nor your clients will be left stranded at the airport. Thank you.
I understand that there has been volcanic eruptions for quite some time on this planet, and it's been a problem for health hazard, for agriculture for a long time, actually for millennia, as I understand, because we have historical data, historical evidence that there were some volcanic eruptions that caused even famines or all sorts of things. So I'm wondering, is this a research that has taken importance recently, or is this something that has been around for a long time? What's the status, the historic status of this discipline? I understand it's quite new, and I have difficulty figuring out why.
Okay. So volcanic ash has been causing problems to society for a long time, as you say. The Icelandic volcano eruption, due to particular weather conditions at the time, which was bringing the ash over to Europe, it caused much more of an issue than we had previously experienced within the recent past. And the extent of the disruption, the media really caught on to that, and it was brought suddenly to the forefront of public attention. And suddenly learning more and minimizing these problems suddenly became top of the agenda, having before people had never really thought about it. So that stemmed a lot of interest and in this kind of research. The more we're thinking about it, then the more we see examples of where this has caused problems in the past and is currently ongoing. So it's more about changing how we think about it and bringing it to our attention than a new risk.
Actually, another AXA research fellow that presented last year about the Tambora eruption of 1815 was also saying that the economic cost of this has totally changed of scale over the last decades.
Yes.
Because
as technology has evolved and society becomes more complex, this risk is just going to escalate. And unless we can better characterize how to minimize this risk, then it will only ever increase.
I know it's quite hard to predict volcanoes eruption over the past 10 or 50 years, but up to you, what would be the regions or volcano we have to take attention to who could be erupting and produce such ash clouds?
Very good question. The place that we do need to keep our eyes on is Iceland. The risk has not gone away. The recurrence time of eruptions in Iceland is on the order of years to decades. We can expect an eruption definitely within the next decade, I'm sure. They occur very regularly, and the unique geographical location of Iceland means that ashes produced are most likely be wind transported to Europe, causing an issue from this direction. So that is why most of my research is still focused in Iceland.
So I wondered if your research is dangerous. Do you have to go and collect your samples when it's erupting, or can you wait until afterwards?
The best time to collect our samples is during the eruption, because then we can collect the sample and instantly be able to correlate it with what is happening at the volcano at the time. So we can really see the links between different shapes of ash and volcanic activity. With regard to danger, I suppose it's a relative term. So we do try to minimize. We look at a range of monitoring data, so earthquake data, gas data, to see whether the volcanic activity is likely to spike when we're in the field. But we do have to get up close and personal, unfortunately.